Hello and welcome to the Sleepy Scholar. I'm so glad you're here. Maybe you're resting under the stars outside, curled up on the couch, or drifting toward sleep after another day orbiting your own little world. Wherever you are, this is your quiet corner of the night, where science leans in close and curiosity stretches its wings. Tonight, we're chasing one of the boldest questions we can ask. Can humans ever leave the Milky Way Galaxy? It sounds like the setup to a science fiction adventure. Rockets breaking free of starlight, explorers crossing into the dark between galaxies. But it's really a question about physics, technology, and the limits of what it means to be human. Don't worry, I'm not here to give you a spaceship blueprint at midnight. Think of this as a cosmic bedtime story, where the galaxy itself is both the stage and the mystery. All you have to do is listen and wonder. If it sparks your imagination, if you find yourself staring at the stars tomorrow night and asking bigger questions, then we've already traveled farther than most rockets ever could. Before we begin, if you enjoy these soft voyages through science, it would mean the world if you tapped the like button, subscribed, or left a comment sharing where you're listening from and what part of the sky you call home. Now settle in, take a breath, and let's step into the vast spiral of the Milky Way and beyond. Picture this. You're lying in bed, trying to drift off, and right above you, if your ceiling suddenly vanished, you'd see a shimmering band of stars stretched across the sky like someone spilt glitter on the world's biggest black canvas. That glowing ribbon? That's the Milky Way, our home galaxy, the big cosmic neighborhood we all unknowingly share. The funny thing is, most people don't even realize that when they look up at that hazy smear of light, they're actually peeking into the beating heart of a spiral so enormous that our little solar system doesn't even register as a speck. If the Milky Way were a city, the sun would be one tiny street lamp flickering on the far side of the suburbs, and Earth, oh, we'd be a single bug buzzing around that lamp. Not very glamorous. Now, here's the wild part. The Milky Way is massive, about 100,000 light years across. That's not take the highway a little longer massive. That's if you drove at highway speed, it'd take you longer than the age of the human species massive. Think about that next time you complain about traffic. And every one of those fuzzy dots in that river of light, they're suns, stars. Hundreds of billions of them, many with their own planets, their own moons, their own stories. In fact, if you go stargazing in a dark place, that soft band you see isn't some fog, it's literally the combined light of countless stars your eyes can't pick apart. Like looking at the Milky Way is squinting at a cosmic crowd, and all you see is their collective glow. So, why beneath your pillow? Because whether you're aware of it or not, you're always tucked under that galactic quilt. Every dream you've ever had has been wrapped in the Milky Way's arms. Your entire life, every laugh, every yawn, every weird snack you've eaten at 2 a.m. has happened inside this swirling spiral. The Milky Way isn't just scenery, it's the container for our entire history. It's where cavemen lit fires, where Einstein scribbled equations, where you're now falling asleep wondering whether humans could ever get out of this stellar cul-de-sac. Before we even consider leaving, we need to picture what this thing actually looks like. The Milky Way is a barred spiral galaxy, meaning it's got long arms that sweep outward in curls, with a chunky bar of stars across its center. If galaxies were pizzas, the Milky Way would be a perfectly spun spiral, saucy arms spiraling out, peppered with billions of star-shaped toppings. Our solar system, we're hanging out on one of the outer arms called the Orion Arm, about two-thirds of the way from the center. Not downtown, not the countryside, just somewhere in galactic suburbia. You could say Earth is basically living in the cosmic equivalent of between the city and the farms, which honestly explains a lot about why we feel both important and insignificant at the same time. Here's something even cooler. The galaxy is alive in motion. Our solar system is whipping around the center at about 500,000 miles per hour. Yes, you heard that right, 500,000 miles per hour. But before you panic and start holding on to your mattress, remember, speed feels different when everything around you is going the same speed. You don't feel the Earth spinning under your feet, and you don't feel the solar system racing around the galaxy. But trust me, we're moving. And at that speed, it'll still take us 225 million years to make a single orbit around the galaxy. That's one galactic year. Dinosaurs were around the last time Earth was on the other side. Makes your birthday feel a little less impressive, doesn't it? Now, when you hear the phrase, "Can humans ever leave the Milky Way?" it almost sounds like we're plotting a road trip. Like, pack some snacks, grab a playlist, and blast off to the next galaxy over. But here's the rub. The Milky Way is so staggeringly big that just trying to leave its edge feels like suggesting you walk across the Pacific Ocean in flip-flops. And that's not even counting gravity, the invisible glue holding this whole spinning carnival ride together. Gravity from billions of stars pulls everything inward, making the Milky Way feel less like a neighborhood you can walk out of and more like a massive spiraling city with no exit. You don't just leave. You'd need speed. Lots of it. But let's pause before rockets and speeds and impossible distances. Right now, think about the intimacy of this thought. You're in bed, pillow under your head, drifting between wake and sleep. And above you, even though you can't see it right now, the Milky Way stretches on. The same view that guided sailors centuries ago, the same band of light that inspired myths about rivers of milk, paths of gods, or stairways to the heavens. People have always looked up and wondered. The galaxy has been whispering to us for as long as we've been able to look up. It feels almost rude not to wonder whether we'll ever actually go beyond it. And here's the strange part. We've barely begun to step outside our front yard. Humanity's farthest traveler right now is Voyager 1, a little spacecraft launched in 1977. As of today, it's about 15 billion miles away, drifting in interstellar space. Sounds epic, right? But compared to the galaxy, Voyager hasn't even left the driveway. If the Milky Way were the size of the United States, Voyager would have traveled about, one step out the door. That's it. And it took almost 45 years to get that far. So, yeah, leaving the Milky Way, that's going to require a lot more than strapping rockets to a tin can. But here's where the fun part comes. Dreaming about it. Science in many ways is the art of giving shape to our wildest what-ifs. And bedtime, the moment when your mind is hovering between alertness and sleep, is the perfect place to play with those ideas. What if we could ride beams of light? What if humans learned to hibernate for centuries like cosmic bears? What if our descendants built ships so large they were floating cities, carrying entire generations toward the edge? Thinking about leaving the Milky Way isn't less about practical planning and more about stretching your imagination until it meets the edges of the galaxy itself. And yet the Milky Way doesn't feel hostile to that thought. It feels massive, sure, but also oddly welcoming. Every star is like a nightlight, reminding you that you're not floating alone. Our galaxy is both cradle and cage, keeping us safe for now, but also making us restless. Isn't that so human, to look at something magnificent, feel awe, and then immediately ask, "Cool, but can we leave?" The truth is, before we can even start packing bags for intergalactic travel, we need to spend more time really knowing our home. To understand the shape of this spiral, to trace its arms, to map the ocean of stars we already live in. because you wouldn't leave your hometown without learning where the streets go, right? Same goes for galaxies. And that is where the story heads next, into the architecture of this colossal spiral we call home. So, as you drift now, tucked under your pillow, imagine yourself not in your room, but floating far above the Earth, looking down at a glittering pinwheel of stars. That pinwheel is your house, your story, your pillow under the night. And the question that lingers, can we ever leave, isn't something you need to answer tonight. For now, all you have to do is dream about what it means to live in a galaxy and prepare to explore its shape when the story continues. If you could pick up the Milky Way and look at it from far above, you wouldn't see some random blob of stars scattered around like spilled sugar. You'd see a shape, a pattern, a kind of cosmic choreography that's been swirling for billions of years. The Milky Way isn't just a jumble, it's a spiral. Picture a pinwheel spinning in the summer sun, or maybe that cinnamon roll you had once that looked almost too perfect to eat. That's the form of our galaxy, arms sweeping out in arcs, curving with a kind of slow-motion grace, while the center blazes like a spotlight in a stadium. The funny part is, for the longest time, we had no clue about this shape. From Earth's surface, the Milky Way just looks like a hazy streak of light smeared across the night sky. People thought it might be some kind of vapor trail, or maybe the gods spilled milk. That's actually where the name comes from. The ancient Greeks looked up, saw that shining band, and called it Galaxius Kyklos, which literally means milky circle. Poetic, sure, but not exactly a scientific description. It wasn't until telescopes came along that astronomers realized, oh, wait a second, that mist is actually billions of stars. Suddenly, the streak in the sky wasn't fog, it was architecture. Now, let's zoom out and describe this architecture. Imagine the Milky Way as a disk, thin compared to its width, like a pancake on a cosmic griddle. The disk stretches about 100,000 light-years across, but only around 1,000 light-years thick. If galaxies were food, the Milky Way would be that crepe you roll up because it's way too flat for its width. And just like a pancake, all the tasty bits, the stars, the planets, the nebulae, are concentrated in that thin layer. At the center of the disk is the galactic bulge. Think of it as the gooey cinnamon center of the roll. A thick, glowing sphere packed with older stars. Right in the middle of that bulge sits Sagittarius A star, a supermassive black hole weighing the equivalent of 4 million suns. Don't panic, it's not sucking everything in like a cartoon vacuum. It just sits there, calmly warping space while stars whirl around it like dancers circling a maypole. This black hole is the anchor, the pivot point that helps shape the motion of the entire galaxy. From that central bulge, the spiral arms unfurl. They're not solid arms the way a cartoon galaxy might suggest, they're more like traffic jams. Stars move in and out of them, but the density waves, the crowding patterns, give the illusion of long, curving arms. It's a bit like watching cars on a freeway. The cars themselves move, but the traffic jam, the slowed cluster, can seem to stick in place. Our solar system is cruising along inside one of these arms, the Orion arm, like a single car traveling through an endless interstellar rush hour. Except here, rush hour lasts millions of years, and the scenery is better. Nebulae glowing in pinks and blues, clusters of young stars burning white-hot, and ancient star clouds like faded billboards on the roadside. If you flew above the Milky Way, impossible for us right now, but let's pretend, you'd see 4 main spiral arms stretching out from the core, curling around like ribbons. Between them are dark lanes of dust and gas, the raw material for new stars. This mix of light and dark, glowing clusters and shadowy gaps gives the Milky Way a texture that's almost alive. It doesn't just sit there, it moves, it breathes, it creates. New stars are born in nurseries of gas, Old stars burn out and collapse, and all the while the galaxy slowly spins, completing a full rotation every 250 million years. Imagine Earth's whole history, dinosaurs rising and falling, humans inventing fire and Wi-Fi, all crammed into one tiny slice of that galactic turn. And the Milky Way isn't alone in its structure. Surrounding the disk like a kind of starry halo is, well, literally a halo, not glowing like a cartoon angel's, but filled with globular clusters, ancient spherical groups of stars orbiting far from the center. These clusters are relics from the early days of the galaxy, fossils frozen in motion, reminding us of a time when the Milky Way was still forming. Inside that halo also lurks dark matter, invisible and mysterious, making up most of the galaxy's mass. We can't see it directly, but without it, the Milky Way's shape wouldn't hold together. It's like scaffolding you can't see but desperately need, like the hidden Wi-Fi router that keeps your whole house connected but is shoved behind the couch so no one trips over it. Now, here's where things get mind-bending. The Milky Way's shape is shaped by more than just itself. Our galaxy is part of a bigger community, the local group. We've got about 50 neighboring galaxies, from big ones like Andromeda to small, scrappy dwarf galaxies. Some of these dwarfs are actually caught in the Milky Way's orbit, being slowly pulled apart, their stars added into our arms. It's a little dramatic, sure, but galaxies are cosmic recyclers. They merge, they absorb, they reshape. That spiral you're imagining isn't fixed, it's dynamic, constantly reworking itself through encounters with neighbors. Now here's what makes all of this even more fascinating. We don't get to see the Milky Way from the outside. Every artist's image you've seen is basically an educated guess based on what we can observe from inside the disk. It's like trying to draw a map of your own house while stuck in the basement. You know there are stairs, maybe you catch glimpses of windows, but the full floor plan has to be pieced together from hints. Astronomers use radio waves, infrared light, and the motion of stars to reconstruct the Milky Way's layout. The picture we carry in our minds, a stunning spiral with a glowing center and graceful arms, is the result of centuries of detective work. So when you close your eyes and imagine the galaxy stretching above you, you're not picturing something random, you're picturing a living structure. Stars born, stars dying, arms curling, gas clouds weaving new light into the fabric of the galaxy. And that shape matters. Because if you want to imagine leaving, if you want to picture what it would mean to sail beyond the Milky Way, you first need to know what you'd be stepping out of. It's not just a glowing streak in the sky. It's a disk, a bulge, a halo, a spiral, a masterpiece of structure. And here's the thought to drift on. The Milky Way isn't just any spiral. It's our spiral, our home base, our launching point. And while it spins on its colossal timescale, carrying us through arms and around the center, you get to ask the next question. What force keeps this structure together? What's the invisible thread pulling stars and planets into that grand spiral dance? That answer, the story of gravity, is waiting in the next chapter. Have you ever tried to escape a hug from someone really strong? Maybe an enthusiastic aunt at a family wedding, or that one friend who doesn't know the meaning of personal space? No matter how much you wiggle, their arms keep you locked in. That, in a way, is what gravity does on a galactic scale. It's the ultimate hugger of the cosmos, the invisible glue that makes sure stars don't just fling themselves into the void, and that you don't go floating off your bed like a balloon someone forgot to tie down. Without gravity, galaxies wouldn't have shape, planets wouldn't stick to their orbits, and frankly, you wouldn't even be here. Let's bring it down to Earth for a second. Literally. Gravity is the reason you don't spill your morning coffee into space every time you take a sip. It's the reason your phone falls when you drop it, not levitates in midair waiting for you to catch it like some polite butler. Sir Isaac Newton first gave us the idea that gravity is a universal force. Every object with mass pulls on every other object with mass. You pull on the Earth pulls on you, and technically your sandwich pulls on you too. Thankfully, the sandwich is too puny to matter, so you don't feel like you're being tackled by your lunch. But scale that up, and suddenly gravity becomes the architect of the universe. In the Milky Way, gravity is the reason stars are packed into a swirling spiral instead of scattered like popcorn in a movie theater after the credits. Billions of stars, gas clouds, and planets are all linked by this invisible handshake. And here's the kicker. A single star's gravity isn't enough to do the trick. You need the combined pull of billions of them, plus something even more mysterious, dark matter. Yep, the galactic glue has a secret ingredient, and we still don't fully understand it. But we know it's there, because without it, galaxies would spin themselves apart like toddlers on a sugar rush, twirling too fast in circles. If you're picturing gravity like an invisible string, that's close, but not quite the full story. Einstein showed us that gravity isn't a force in the old-fashioned sense. It's space itself bending around mass. Imagine putting a bowling ball on a trampoline. The trampoline dips, and a marble rolled nearby will spiral inward, not because the bowling ball reached out and grabbed it, but because the marble is following the curve of the trampoline. The galaxy is like that, but on steroids. Stars and planets are bowling balls of different sizes, all warping the cosmic trampoline, and their combined effect keeps everything in a grand spiral dance. Now, here's where it gets even more fascinating. Gravity may feel strong to you, it's why lifting a couch makes you break into a sweat, but compared to other fundamental forces, it's astonishingly weak. Magnetism, for example, can overpower gravity with the tiniest effort. A refrigerator magnet holds up a photo against the pull of the entire Earth. That's like a flea stopping a freight train. And yet gravity wins in the end, because it never cancels out. Electric charges can cancel, magnetic poles can balance, but gravity, it just keeps adding up. Every star, every planet, every particle piles onto the cosmic scale, and together they dominate the shape of the universe. On the scale of the Milky Way, gravity is the reason our solar system orbits the galactic center. Think of it as us being in a giant merry-go-round, except instead of cheerful carnival music, the soundtrack is a billion years of cosmic silence. We zip around the center of the galaxy at over 500,000 miles per hour, but we never fly off because gravity won't let us. It's not holding us by force, it's curving space so that what feels like a straight path is actually a giant orbit. If the galaxy's gravity suddenly turned off, don't worry, it won't. We'd shoot off into intergalactic space like a bowling ball hurled down an alley with no pins at the end. But here's the thing. Gravity isn't just a galactic tour guide. It's also a gatekeeper. To leave the Milky Way, you'd need to reach something called escape velocity, the speed required to break free from a gravitational pull. On Earth, that's about 25,000 miles per hour, manageable with rockets and a lot of fuel. For the galaxy, though, you'd need to move at nearly 1,200 kilometers per second. That's around 2.6 million miles per hour. Even if you strapped a rocket to your favorite sports car, added all the caffeine in the world, and ignored traffic laws, you'd still be painfully slow. Our fastest spacecrafts today wouldn't even come close. The Milky Way's gravity isn't just a hug, it's a bear hug with no intention of letting go. And yet, without that hug, the Milky Way wouldn't even exist. Gravity shapes the arms, pulls stars together to form new ones, and tucks planets neatly into orbits where life has a chance to evolve. In a way, you owe your entire existence to gravity's persistence. Every heartbeat, Every memory, every silly dance you've ever done in your kitchen happened because gravity allowed Earth to form, the sun to shine, and galaxies to hold themselves together long enough for life to get started. It may be invisible, but it's the most reliable partner you've ever had. So the next time you think of gravity as a nuisance, like when you trip over nothing or your ice cream scoop falls off the cone, you might remember that it's also the reason stars sparkle at all. It's the universe's most loyal glue, unseen but essential. But if you're dreaming of leaving the Milky Way, this is the obstacle you'll have to reckon with. Gravity isn't going to hand you the keys and wave goodbye. You'll have to outwit the cosmic glue itself, which is easier said than done. As you drift into thought, picture yourself standing on the edge of the galaxy's disk, staring outward. The stars behind you are bound by the invisible embrace of gravity, while in front of you lies a darker, emptier expanse. How would you even begin to take a step into that darkness? The answer may lie not in gravity itself, but in the light it lets escape. And that's where the story is headed next, into the strange role of light as a messenger and what it can reveal about the edges we long to cross. Have you ever stopped mid-stargaze and thought, wait a second, am I basically time traveling right now? Because every time you look up, that's exactly what you're doing. The light reaching your eyes is ancient mail, delivered on beams that left their sources long before TikTok, long before the dinosaurs, even long before Earth had breathable air. Imagine opening your inbox and finding a letter that was mailed 10,000 years ago. That's starlight. The sky is essentially the universe's postal service, except the delivery is free, the stamps are nuclear furnaces, and sometimes the messages arrive billions of years late. Light is more than brightness, it's information. Think of it like cosmic gossip. Every star, every galaxy, every flaming ball of plasma in the distance is spilling its secrets through light. When we catch that glow, we're not just seeing a twinkle, we're eavesdropping on a conversation across time. The star Sirius, you're seeing it as it was about 9 years ago. Betelgeuse, over 600 years ago. Which means when you look at it tonight, you're seeing a snapshot from an era when Europe was obsessed with knights and castles. Light lets you spy on the past without a time machine, which is pretty convenient since nobody's cracked the DeLorean blueprint yet. Now here's where it gets deliciously strange. Light moves at the universe's ultimate speed limit, 299,792 kilometers per second. That's fast enough to loop Earth more than 7 times in a single second. If Superman actually tried to fly around the Earth to turn back time, as in the movie, he'd have to beat that speed limit. Spoiler, not happening unless he's packing some physics-breaking cheat codes. But for photons, this speed is standard cruising velocity. They leave stars, skip across interstellar space, and arrive at your eyeballs without even asking for a snack break. But light isn't just punctual, it's a storyteller. The color of light tells you the temperature of its source, like cosmic mood lighting. Blue light, the star is hotter than a pizza oven cranked to lava. Redder light, cooler, though still far toastier than your average summer day. Astronomers have learned to decode these hues the way detectives study handwriting. By splitting starlight through a prism, we can read its spectral fingerprints, tiny dark lines that reveal what elements the star is made of. Hydrogen, helium, oxygen, it's all written in the light. Suddenly, the sky isn't just pretty, it's a library. If you think about it, photons are absurdly dedicated messengers. Imagine a particle leaving a galaxy billions of light years away, threading its way past black holes, dodging dust clouds, avoiding collisions, never getting lost, and finally making landfall in your cornea. Also, you can look up for 2 seconds and say, huh, neat star. That's loyalty. But light doesn't only whisper about stars, it also sketches the boundaries of our galactic home. Astronomers map the Milky Way by following streams of starlight, tracing how they bunch into spiral arms and scatter in cosmic dust. Without light, the galaxy would be like a darkened concert hall. You'd know there was a structure, but you couldn't make sense of the seats, the stage, or the crowd. With light, the house lights come on, and suddenly you see where the spiral arms curl, where clusters glow, and where shadows hide in clouds of gas. It's as if the galaxy has been drawing its own self-portrait, one photon at a time. Of course, not all light makes it to us in a straight line. Some gets bent. Gravity, that cosmic puppeteer we met earlier, can warp space-time so dramatically that even light has to bow and follow the curve. Astronomers call this gravitational lensing, but I like to think of it as the universe's Instagram filter. Galaxies in the background look stretched, smeared, or magnified, not because of bad eyesight, but because a massive object, like another galaxy cluster, sits between us and them, bending their light. Thanks to this warped glow, scientists can see objects otherwise too faint or far away, as if the cosmos handed us a giant magnifying glass. Now let's talk about timing, because if light is a message, then distance is just delivery delay. The farther away the source, the older the news. When we look at the Andromeda Galaxy, our next-door neighbor, we're seeing it as it was more than 2 million years ago. Back then, our ancestors hadn't even invented fire yet. By the time that light hit Earth, humanity had gone from cave paintings to space telescopes. And if you stretch your gaze farther still, to galaxies 10 billion light-years away, you're peering into the universe's baby pictures. These aren't just stars twinkling, they're time capsules. That's where the idea of a cosmic horizon comes in. There's a limit to how far we can see. Not because the universe has walls, but because beyond a certain distance, light hasn't had time to reach us yet. It's like showing up to a party so early that the DJ hasn't even plugged in the speakers. You can only experience what's already started. That horizon marks the edge of our observable universe, and every beam of light we catch inside it is a note from history saying, "This is how things looked when I left." What's wild is that we're not just passive receivers of this light. We can, in theory, chase it. Imagine a spaceship designed to surf on beams of photons, like writing cosmic Wi-Fi signals across the dark. Scientists have already dreamed up concepts like solar sails, thin, reflective sheets that catch the push of sunlight like a kite catches the wind. It's not science fiction. Prototypes have already flown. If scaled up, such sails could, in principle, ride the light from our own star out of the solar system, maybe even towards nearby stars. It would take decades or centuries, but the idea is seductive, using the universe's messenger as a highway. Of course, the speed of light is also our ceiling. Nothing with mass can hit that velocity without requiring infinite energy, which is nature's way of saying, don't even try it. So no spaceship of ours will ever catch up to the very beams of starlight already streaking past us. But we can dream of riding alongside new photons, fresh from our sun, hitchhiking across the void with sails spread wide. It would be less like piloting a rocket and more like drifting with the wind across an endless ocean. But even if we stay put, light still teaches us how to leave home. By measuring the faint redshift in distant galaxies, the stretching of their light as the universe expands, we discovered that everything is flying apart. The universe isn't a static backdrop, it's an inflating balloon, and light is the ink stretching across its surface. This revelation not only showed us the universe has a beginning, but also hinted at its possible fates. And all of that came from photons, those tireless couriers racing through space. Next time you stare at the stars, remember you're not just seeing sparkle, You're decoding the autobiography of the universe written in light. Each photon is both historian and traveler, carrying news across unimaginable gulfs of time and space. And as we learn to read this language, we edge closer to knowing whether humanity could ever leave the comfort of its spiral arms and follow those luminous breadcrumbs into the great unknown. Because here's the real question lingering at the edge of this thought. If light can travel across billions of years to reach us, could we ever follow it out, step by step, into that vastness? Maybe. But before we even try, there's another messenger waiting to be understood. One that doesn't just travel through space, but bends and folds it. To chase the light fully, we'll need to learn how time itself can warp. And that's where our journey heads next. Have you ever thought about how unfairly small Earth's oceans are compared to the real ocean we're floating in? Don't get me wrong, the Pacific is impressive. It can swallow continents on maps and still burp. But compared to the Milky Way, it's basically a backyard puddle after rain. Picture instead an ocean where each wave is a sun, where currents carry whole clusters of stars, and where the dark stretches deeper than any abyss humanity has ever dared to sound. That's the ocean of stars we live in. And whether you know it or not, you've been adrift in it since the day you were born. The Milky Way is 100 billion stars strong, a population so huge you'd need thousands of lifetimes just to count them, assuming you never stop to eat, sleep, or binge-watch another season of whatever show people are addicted to in the year 5000. It isn't a flat sheet of lights, it's a disk, spiraling with arms like a cosmic hurricane, stretching more than 100,000 light-years across. A light-year, by the way, is the distance light travels in a year, and that's about 9.5 trillion kilometers. Stack enough of those together and you realize the Milky Way is less like a neighborhood and more like the ultimate interstellar cruise ship, except one where nobody invited us to the captain's table. Floating here, you'd notice something fascinating. Stars aren't sprinkled evenly, like salt over fries. They clump into patterns, clusters, associations, families. Some stars travel together in tight knots, like close-knit cousins who refuse to leave the same block. Others shine in huge groups called globular clusters, those glowing spears of stars that look like disco balls hanging at the galaxy's edge. Then there are lonely wanderers, rogue stars drifting like lost boats on a black sea with nothing but gravity to tug at their sleeves. The ocean of stars has currents and tides, invisible but powerful, shaped by the pull of mass and motion. The real trick is trying to wrap your brain around the scale. If our solar system were shrunk down to the size of a coin, the Milky Way would still sprawl wider than the continent of North America. Imagine flicking that coin into a football stadium and then realizing the stadium is only a microscopic patch of the actual field. That's how small we are compared to this galactic sea. And yet, here we are, talking about it, staring into the darkness, daring to imagine crossing it. Humanity doesn't lack ambition, we've just got inconvenient physics standing in the way. The distances between stars in this ocean are vast beyond reason. Take our nearest stellar neighbor, Proxima Centauri. It sits only 4 light-years away, which sounds cozy, until you realize that's 40 trillion kilometers. Even if you could travel at the speed of the fastest spacecraft humans have ever built, you'd need tens of thousands of years to get there. That's not a road trip, that's an epic saga where your descendants would finish the journey long after your name had faded into myth. It would be like setting out from Earth in the Stone Age and finally arriving today. The ocean of stars is less like the Caribbean and more like the Pacific multiplied by infinity. And yet, we keep trying to imagine boats for this sea. Instead of sails catching wind, we imagine sails catching light, using the push of photons to glide between suns. Instead of compasses, we dream of navigation guided by pulsars, those spinning neutron stars that tick like cosmic lighthouses. The journey wouldn't feel like a voyage across a stormy surface, but more like drifting in silence, with nothing moving except the glow of distant stars, slow and steady as the tide. You could travel for years and still look back to find Earth's sun a shining speck in the endless dark, like a lighthouse dwindling on a horizon you'll never return to. And think about what it would be like to swim in this starry ocean with eyes tuned beyond human limits. You'd see colors we miss now, stars blazing in blues, oranges, and reds, like bioluminescent creatures in the deep. Clouds of gas would glow like coral reefs, birthing new stars in slow, luminous blossoms. Black holes would lurk like trenches, invisible but dragging the currents around them. The Milky Way isn't static, it's alive, shifting and spinning, its stars orbiting the center as if caught in a slow, eternal whirlpool. Even our own sun is part of the current, drifting around the galaxy once every 225 million years. We're all passengers on this ride, whether we realize it or not. Now, here's where the metaphor really sticks. On Earth's oceans, explorers have always launched themselves into the unknown, convinced that across the horizon lay riches, new lands, or answers to impossible questions. Sometimes they were right, sometimes they fell off the edge of their maps, but they always pressed forward. Humanity seems wired for this kind of curiosity. The stars are our new horizon, the Milky Way, our ultimate sea. We may never master it completely, just like no sailor has ever mastered every tide, but we're already building ships that dream of sailing further than our planet's shores. And as you float in this thought experiment, picture how lonely, yet crowded, the galactic sea is. Lonely because the void between suns is staggering, but crowded because those billions of stars are still there, watching, shining, whispering their stories through light. Every star could cradle its own planets, its own stories, maybe even its own forms of life, wondering the same thing about us. To them, we'd be just another point of light, a distant shimmer across their ocean. The possibility is dizzying. It's like standing at the shore and realizing that across the waves, other fires might be burning, unseen but real. When you really let this idea sink in, you feel a mix of awe and vertigo. The ocean of stars isn't there to comfort us. It isn't built for human scale or human needs, but it's there, and it dares us to imagine ourselves as something more than earthbound creatures. Maybe our sails will one day stretch wide enough to ride the starlight between suns. Maybe we'll learn to navigate the currents of gravity and time. Or maybe, like so many sailors before, we'll discover wonders we can't yet imagine, hidden in the folds of this galactic sea. For now, though, we float in the shallows, gazing outward, trying to understand. The ocean of stars is vast, merciless, dazzling, and it holds both danger and promise. It is the backdrop of every dream humanity has ever had about the cosmos. And as we prepare to sail further in our minds, the question isn't just how far we can go, it's what mysteries this ocean might be hiding in its deepest trenches. Because if starlight carries stories from the past, and if gravity holds the galaxy together, then perhaps the ocean itself conceals something even stranger, a truth waiting to be uncovered. And that is where our voyage is about to take us next. Have you ever noticed how obsessed we are with speed? From the first time someone figured out a wheel rolls better than a square rock, humans have been hooked on going faster. Horses, chariots, trains, cars, planes, rockets. Every new invention is basically a screaming into the void, "Not fast enough!" Even now, when you complain that your Wi-Fi is lagging, what you're really saying is, "I want information to travel at light speed and I will not settle for less." It's as if humanity has always been chasing the cosmic speed limit without quite knowing what it means. So, what happens if you actually try to chase light? Strap in, because this is where physics pulls the rug out from under you and giggles. You'd think that the faster you go, the faster you get where you're going. Logical, right? Wrong. Einstein showed us that once you start approaching light speed, the universe basically changes the rules of the game. Time stretches, distances warp, and suddenly you're not just traveling through space, you're messing with time itself. It's the ultimate cheat code, but it comes with side effects that make you rethink every action movie chase scene you've ever watched. Let's paint a picture. Imagine you're in a spaceship, cranking the engines to ridiculous levels. As you inch closer to light speed, strange things start happening. Back home on Earth, your friends are still binge-watching shows and ordering takeout. But for you, time inside the ship slows down. This isn't an illusion. It's real. Seconds for you could be hours, years, or even centuries for them. This effect is called time dilation, and it means that by moving faster, you actually age slower compared to those who stayed behind. It's not sci-fi. It's a law of nature, baked into the very fabric of the universe. One of the most famous thought experiments that explains this is called the twin paradox. Picture two twins. One hops on a spaceship and blasts off at near light speed. The other stays home. When the traveling twin returns, they're younger than their sibling. They didn't use fancy skincare or secret elixirs, they just experienced time differently because of their speed. For the traveler, maybe only a few years passed. For the twin at home, decades rolled by. This is where physics gets personal, making you wonder whether fast travel is a shortcut or just a way to get out of family reunions. Of course, this has a catch. The closer you get to light speed, the harder it is to gain more speed. Your ship's mass effectively increases, demanding more and more energy. Imagine trying to sprint with a backpack that grows heavier every step you take. Eventually, the bag becomes so crushing you can't move another inch. That's why nothing with mass can reach the speed of light itself. It would take infinite energy. The universe doesn't hand out infinite anything, no matter how politely you ask. Still, let's not be too discouraged. Even if we can't reach light speed, playing around near it has mind-bending possibilities. Think about interstellar travel. Say you wanted to visit a star 20 light-years away. From Earth's perspective, that's a long wait. You'd need decades just to cover the distance. But if you were traveling at near light speed, time dilation would make the trip feel much shorter for you inside the ship. From your perspective, maybe only a few years tick by, even though Earth experiences decades. It's like skipping to the end of a movie while everyone else watches it in real time. This idea makes speed feel almost magical, like a ticket not just through space, but into the future. Because here's the sneaky part. If you leave Earth, zoom around near light speed, and then come back, you will have effectively traveled into the future relative to everyone who stayed. They will have aged, society will have changed, new music will confuse you, and your favorite snack might have been discontinued. For you, only a small slice of time passed, but for them, history marched on. Light speed travel isn't just transportation, it's a one-way ticket to tomorrow. But before you grab your keys and try to fire up the spaceship, let's remember the energy problem. Accelerating to such speeds requires absurd amounts of fuel, far more than we could ever hope to carry. You can't exactly duct tape gas tanks to the wings of a starship and hope for the best. The challenge isn't just about inventing faster engines, it's about redefining how we even think about propulsion. Ideas like antimatter drives or light sails come into play, but for now, they're sketches in the margins of physics, not blueprints on an assembly line. Speed, then, is both thrilling and frustrating. It teases us with possibilities, crossing galaxies, skipping centuries, bending time like it's origami paper. And yet, it also reminds us of the limits we face. We may dream of outrunning the Milky Way's pull, but time dilation shows us that the closer we try to get, the stranger the journey becomes. Our bodies, our clocks, our very sense of reality all start to wobble. It's like physics is saying, sure, you can play with my toys, but don't expect the rules to stay the same. So as you rest with this thought, imagine drifting in your ship, watching stars smear into streaks of light, feeling time itself bend around you. You'd be both moving faster than anyone has ever gone and slower than you can possibly imagine. That's the paradox. The speed of dreams is not just about motion, but about time, about what it means to live in a universe where space and hours are knotted together. And as your ship steadies into that impossible pace, a new question rises. If speed bends time, what happens when you face the one barrier that even light itself cannot outrun? That's where our story sails next, toward the cosmic shadows we call black holes. Picture yourself standing next to a rocket at liftoff. The ground shakes, your chest vibrates like you've accidentally turned yourself into a human subwoofer, and there's a noise so loud you wonder if your ears will ever forgive you. Rockets are the drama queens of transportation, loud, fiery, and with an appetite for fuel that makes your car's gas mileage look saintly. And yet, for all that spectacle, they're barely scratching the cosmic surface. They can get us to the moon, sure, maybe Mars if we're patient and a little stubborn, but when you start talking about crossing the galaxy, rockets look less like heroes and more like toddlers with water pistols trying to put out a forest fire. Here's the raw truth. Our current rockets are basically glorified firecrackers, burning chemical fuel to push against gravity. They work brilliantly for escaping Earth's clingy grip, but they're hilariously inefficient for deep space. The Saturn V, the giant that carried Apollo astronauts to the moon, guzzled fuel like it was at an all-you-can-eat buffet. To get a tiny capsule into space, most of the rocket was just massive fuel tanks. Imagine if you needed an entire tanker truck of gas just to drive across town. Suddenly, you're not so impressed with the ride. So, humans started dreaming up quieter, smarter, less flame-throwing ways to move through space. Enter the ion drive. If rockets are heavy metal bands smashing guitars on stage, ion drives are lo-fi playlists, subtle but steady. They don't roar, they whisper. Instead of fire and smoke, they throw ions, charged particles, out the back at ridiculously high speeds. The push is tiny, so small that if you tried to use an ion drive to leave a parking lot, you'd still be sitting there while your coffee got cold. But in the vacuum of space, where there's no friction to slow you down, that steady push adds up. After months or years, an ion drive can actually reach much higher speeds than a chemical rocket. NASA's Dawn spacecraft, which explored the asteroid belt, was powered by an ion engine that could, over time, accelerate to tens of thousands of miles per hour. It's not flashy, but it's patient, like a tortoise in a race where the hare ran out of snacks halfway through. Still, even with ion drives, we're talking about journeys that take decades just to reach nearby stars. And decades are nothing compared to the scale of the galaxy. At that point, you start wondering if we should just leave postcards instead of trying to visit. That's where the dreamers start dusting off their science fiction shelves and say, what about antimatter? Antimatter is the ultimate opposite-day particle. For every bit of matter, like the protons and electrons that make up you, me, and your coffee mug, there's a mirror version with opposite charge. When matter and antimatter meet, they don't shake hands, they annihilate in a burst of pure energy. And not just a little energy, complete conversion. If you could somehow fuel a spaceship with antimatter, the energy payoff would be staggering. A single gram of antimatter, about the size of a paperclip, could unleash as much energy as a nuclear bomb. Suddenly, the idea of crossing the stars doesn't seem so laughable. Except for one catch. Antimatter is ridiculously hard to make and even harder to store. We can create tiny amounts in particle accelerators, but it takes more energy to make it than we'd ever get back from using it. It's like paying $100 to mint a penny. Impressive, but not helpful if you're trying to buy groceries or cross the galaxy. Of course, there are other ideas floating around, and some sound like they were cooked up during a late-night sci-fi movie marathon. Fusion engines, for instance, would use the same process that powers the sun, smashing light atomic nuclei together to release massive amounts of energy. In theory, fusion engines could give us a steady, powerful push without guzzling resources like chemical rockets. The trouble is, despite decades of trying, we still haven't built a working fusion reactor on Earth that produces more energy than it eats. The universe is out there saying, hey, just copy me. And we're like students staring at the smartest kid in class, realizing we can't. Yet. Then there are sails. Solar sails or laser sails, giant, ultra-thin sheets that catch light itself as a form of propulsion. It sounds poetic, doesn't it? Riding sunlight like surfers on cosmic waves. Light has no mass, but it carries momentum, and with enough sail area, photons can nudge a spacecraft forward. Again, the push is tiny, but relentless. Projects like Breakthrough Starshot imagine sending tiny probes to nearby stars, using powerful Earth-based lasers to blast them across space at a significant fraction of light speed. It's like giving a paper boat a fire hose push. Elegant in theory, but the engineering challenges are enormous. The sails have to survive intense laser power without shredding, and the probes need to somehow communicate back across light years. Not easy, even when your Wi-Fi struggles with a thick wall. Every engine idea, from roaring chemical rockets to whispering ion drives to sci-fi level antimatter, runs into the same wall: scale. The Milky Way is massive. Even the nearest star system, Alpha Centauri, is over 4 light-years away. With our fastest current technology, it would take tens of thousands of years to get there. Tens of thousands! By the time your spacecraft arrives, your great-great-great many times great-grandkids would be asking, wait, who even sent this thing? The limits of engines aren't just about physics. They're about patience. Space isn't impressed with our timelines. Rockets, ion drives, antimatter dreams. They're all lanterns in the dark, hopeful sparks against the backdrop of infinity. They remind us of our ambition, but also our smallness. Every time we light an engine, we're basically saying to the cosmos, hey, we're trying. And the cosmos, with its billion-year stare, shrugs and says, good luck, you'll need it. Still, there's something beautiful about that. Rockets may be small against the galaxy, but they're enormous for us. They've already taken us beyond our atmosphere, to the moon, to other planets, and out into the interstellar neighborhood. The Voyager probes, running on nuclear-powered generators, are already in interstellar space, drifting further than anything humans have ever built. Their engines are off now, but their journey continues. A reminder that even the smallest lantern can light part of the dark. So are engines the way to break free of our galactic cradle? Maybe not. Maybe they're just the first sparks, stepping stones to something stranger, something that doesn't push us through space but bends space itself. Because if engines roar and whisper, space-time might hum in ways we've only begun to imagine. And that hum is where we're headed next, into the wild idea of turning the fabric of the universe into our highway. Imagine packing your bags for the ultimate road trip. You've got snacks, a playlist, maybe even a travel pillow, because we're heading to the next galaxy. Sounds like fun, right? Except here's the catch. Between us and our galactic neighbors lies a stretch of space so vast and empty, it makes deserts look crowded and oceans look cozy. If the Milky Way is your hometown, the gap between galaxies is the cosmic version of driving across a country where every gas station is closed, every restaurant is boarded up, and your GPS just shrugs and says, "Good luck, buddy." This emptiness is what scientists call intergalactic space. And if you're picturing it as just more stars sprinkled across the void, let me stop you right there. Stars mostly live inside galaxies, huddled together like glowing cities. Step outside the galactic city limits, and the streetlights switch off fast. The further you drift, the darker it gets, until you realize that the nearest star is no longer just a hop across the block, it's millions of light years away. That's not a long walk, that's a commitment on a level that makes even marriage look casual. So what exactly fills this intergalactic gulf? The short answer? Not much. But not much in cosmic terms still hides a few surprises. Space is never completely empty. Even in the loneliest corners between galaxies, there are stray atoms of hydrogen gas floating around, stretched so thin that if you scooped up a volume the size of your living room, you might only find a handful of atoms. Not molecules, atoms. Imagine moving into a new apartment and realizing the fridge contains half a grape. That's the intergalactic pantry for you. And yet, emptiness has its own strange beauty. Between galaxies, there are rivers of invisible matter, dark matter to be specific, forming a giant web that binds the universe together. Astronomers call it the cosmic web, a vast three-dimensional lattice that looks uncannily like a spider spun it after drinking too much caffeine. Galaxies gather along these filaments like dewdrops clinging to strands of silk, while the gaps between them stretch into immense dark voids. To drift into one of these voids would be like rowing into an ocean where the horizon never ends, except the water isn't water, and the waves are replaced by silence so deep you'd think the universe turned its volume down to zero. It's not only a test of imagination, it's a test of perspective. If our Milky Way is an island, then the space between galaxies is the ocean. But not the kind with seagulls and tropical breezes. This is an ocean so wide that even light takes millions of years to paddle across. Think about that for a second. Light, our universe's speed demon, the fastest thing we know, still needs eons to cross the gap. If light had a watch, it would sigh, check the time, and say, "Yeah, I'll get there eventually." Meanwhile, we humans are still congratulating ourselves for shaving an hour off a plane flight. And this isn't just poetic exaggeration. Our closest galactic neighbor, the Andromeda Galaxy, is about 2.5 million light-years away. Let's play with that number. If you hopped in a spaceship going as fast as Voyager 1, the fastest thing we've ever launched, it would take you over 40 billion years to get there. Spoiler, the universe itself is only about 13.8 billion years old. Translation, you'd arrive after the universe closed up shop and turned the lights off. Imagine booking a hotel only to find out the entire city no longer exists. That's intergalactic travel for you. Of course, science fiction loves to blur these numbers with warp drives and wormholes. Writers look at the yawning gap between galaxies and say, let's just bend space-time, which, to be fair, is a pretty creative workaround. But if you're playing by the current rules of physics, you quickly realize that crossing the void is less like a road trip and more like an endurance marathon with no finish line. The emptiness is so profound, it challenges not only engineering, but imagination. Could humans ever build something sturdy enough, patient enough to wander through such silence? But here's a fun twist. Even in these dark expanses, you're never completely alone. The intergalactic medium, the sparse gas and dust scattered between galaxies, does leave its fingerprints on light traveling across the void. As photons from distant galaxies make the long trek to us, they pass through this thin haze and get stretched, bent, and sometimes absorbed. Astronomers study these faint changes to map what's otherwise invisible. It's like trying to find a ghost by checking how much colder the room feels when you walk through it. And then there are the rogue stars. Yes, some stars don't stay neatly inside their galactic homes. Through cosmic collisions or gravitational slingshots, a few unlucky or maybe adventurous stars get flung into the intergalactic wilderness. They shine alone, untethered to any galaxy, drifting like lanterns on an endless dark sea. If you were to travel through the void, you might spot one of these solitary lights, a reminder that even the emptiest stretches of space hold rare treasures. They're like gas stations in the middle of a desert, rare, dimly lit, but very welcome. This great expanse also puts into perspective how precious galaxies really are. They're not just random clusters of stars, they're safe harbors in the universe mostly made of wilderness. Inside a galaxy, you've got warmth, light, heavy elements for planets, and the raw materials for life. Outside, you've got, well, hydrogen atoms and a long, lonely commute. In a way, the gap between galaxies makes galaxies themselves feel like bustling oases, rare little hubs in an otherwise sparse desert. The emptiness makes the fullness stand out. Still, it's tempting to think of this vast space as wasted, like the universe could have done us a favor and sprinkled in more stars. But maybe that's the wrong way to look at it. The voids give the cosmos its architecture. Without emptiness, the galaxies wouldn't form into the stunning patterns we see today. Imagine a painting with no blank canvas, a song with no pauses, a story with no silence between words. The gaps give meaning to the clusters just as much as the stars themselves. So what would it feel like to truly drift there, beyond the warm embrace of our Milky Way? Imagine watching your galaxy shrink behind you, first the spiral arms folding into a faint smudge of light, then disappearing altogether. Ahead, nothing but darkness, the occasional flicker of a rogue star, and the whisper-thin trace of gas. Time would stretch until years felt like seconds and seconds felt like years, because without landmarks, without change, the mind struggles to measure passage. Would you find peace in that endlessness? Or madness? It's not a trip we're likely to take anytime soon. Even our most ambitious spacecraft will remain forever bound to our galactic neighborhood. But imagining the journey is part of the adventure. The great expanse between galaxies is more than just distance. It's a reminder of scale, of patience, of the universe's strange balance between emptiness and abundance. It asks us to consider how tiny we are, but also how bold we must be to even think of crossing such distances. And maybe that's the secret of the void. It's not a barrier, but a stage. On it, galaxies shine all the brighter, scattered like islands across the deepest sea. And as we dream of crossing it, we set our sights not just on survival, but on storytelling. What tales we'd carry to the next shore of light, and how the darkness in between would shape us. Imagine being at a dance party where the floor stretches not just across the hall, not just across the city, but across billions of light years. The lights are dim, the music is slow, and the dancers are so large that calling them big feels like calling Godzilla a lizard with ambition. This is the ballroom of the universe, and the dancers are galaxies. Each one is a swirl of stars, dust, gas, and mysterious dark matter moving together like a single, luminous partner. But here's the thing, they don't stay still. They spin, they sway, they drift toward each other, and sometimes they crash. Yes, galaxies are constantly dancing, and like any good choreography, their moves reshape the stage itself. Let's start with the one we know best, the Milky Way. It spins like a cosmic record player, stars orbiting the center as though tethered to some invisible DJ booth. That DJ, of course, is a supermassive black hole named Sagittarius A star, sitting at the heart of the galaxy. Now, black holes get a bad reputation. People imagine them as cosmic vacuum cleaners, ready to slurp up everything in sight. But really, Sagittarius A star is more like a patient instructor, keeping the stars on beat. Without it, our galaxy wouldn't have its graceful spiral arms or its elegant balance. Imagine a dance floor with no center, it would turn into a mosh pit in seconds. But the Milky Way isn't dancing alone. Our nearest partner, the Andromeda Galaxy, is heading straight toward us. Don't panic yet, we've got about 4 billion years before the two finally embrace. When they do, it won't be a catastrophic crash with fiery explosions. Space is mostly empty, so the stars inside each galaxy will likely pass right by each other without colliding. What will happen instead is a long, swirling tango. Their shapes will stretch, twist, and eventually merge into something new, perhaps an elliptical galaxy nicknamed Milky Way. It's the ultimate slow dance, so slow you'd need patience on the scale of civilizations just to watch one step. This kind of choreography isn't rare. In fact, galactic collisions are one of the universe's favorite moves. Astronomers have captured breathtaking images of galaxies caught mid-dance, spirals tugged into tidal tails like skirts flaring mid-twirl, or bright cores circling each other in a cosmic do-si-do. These encounters often spark a frenzy of new star formation. Clouds of gas crash together, compress, and ignite, like someone tossing a whole crate of fireworks onto the floor just as the band hits its peak note. Suddenly, the galaxy lights up with fresh stars, dazzling like a disco ball cranked up to 11. And just like human dancers, galaxies come in all styles. Spirals are the show-offs, flaunting elegant arms that sweep outward like skirts caught in motion. The ellipticals are the wallflowers, big, round, and kind of featureless, but steady and reliable. Irregular galaxies are the breakdancers, all chaotic angles and unexpected moves, shaped by collisions and gravitational tugs. Every type adds its own rhythm to the cosmic choreography. But how do galaxies know their steps? The answer is gravity, the music that plays across the ballroom of the universe. Gravity is subtle but persistent, pulling galaxies together, nudging their paths, shaping their spins. It doesn't need drums or violins, it's just there, always humming, always setting the tempo. When two galaxies are close enough, gravity takes over and the dance begins. You can think of it as cosmic matchmaking. Gravity is the DJ pairing up galaxies, and the rest is pure improvisation. Here's where it gets really cinematic. Galaxies don't just dance with each other, they move through vast clusters, weaving in and out of crowds. These clusters can contain hundreds or even thousands of galaxies, all orbiting a common center of mass. Imagine a flash mob in a city square, only the performers are made of stars and the square is a few million light-years wide. The result is a scene so grand it makes Broadway look like a backyard recital. Of course, some dances end differently. When small galaxies approach bigger ones, they often get swallowed. Our Milky Way has already gobbled up dozens of dwarf galaxies, pulling their stars into long ribbons that now weave through the sky. It's cosmic cannibalism, sure, but it's also a way of growing. Like a dance partner who brings snacks to the floor, those little galaxies fuel the larger one with fresh stars and new material. All this movement might sound like chaos, but there's a strange harmony to it. On human timescales, galaxies seem frozen, like still photos of dancers mid-twirl. But stretch your imagination across billions of years, and you see the choreography unfold. Spirals colliding, cores merging, arms stretching, clusters shifting. The universe isn't static, it's alive with motion, and galaxies are its most graceful performers. And if you're wondering where we fit into all this, Earth, the Sun, our solar system, we're just one tiny speck in one arm of the Milky Way, moving right along with the dance. Every sunrise, every birthday candle, every late-night snack happens aboard a spaceship swirling through space at hundreds of thousands of kilometers per hour, and we don't even notice. It's like being on a spinning dance floor and still managing to sip your drink without spilling. So, when you look up at the night sky, remember, you're not just gazing at stars, you're watching a cosmic performance that's been going on for billions of years. Every light is part of a larger pattern, every galaxy has a role, and the choreography is still unfolding. The Milky Way and Andromeda are slowly gliding toward their duet, clusters are spinning in grand formations, and somewhere out there, new stars are bursting into being as galaxies embrace. But this dance has another layer that isn't always so graceful. because as galaxies swirl and merge, they also tell us something about the hidden structure of the universe. Dark matter, this invisible scaffolding, holds galaxies together and choreographs much of the movement. Without it, the dance would unravel. What is this mysterious partner, and why does it never take a bow on stage? That's the mystery waiting in the wings, and that's where our story sways next. Picture yourself walking to the edge of a vast, ancient tapestry. Up close, the weaving is thick, colorful, and intricate, threads crossing, knots hidden, patterns unfolding. But then, as you keep walking, the fabric starts to fray. Threads thin, gaps open. Eventually, you're standing at the rim where the cloth ends, and beyond it there is only open air, unstitched and endless. That's the edge of our galaxy. Not a wall, not a barrier, but a thinning frontier where stars taper off and darkness takes over. If the center of the Milky Way is a bustling city with neon lights and crowded streets, then the edges are the suburbs fading into countryside until suddenly you're standing on the last streetlight and staring into miles of unlit farmland. The Milky Way, our galactic hometown, is a disk about 100,000 light-years wide. Most of its stars live in the dense middle, spiral arms glowing with stellar neighborhoods, gas clouds, and clusters. But as you move outward, the crowd thins. The suburbs of the galaxy are not quiet retirement communities, but sparse, lonely stretches where stars live far apart, like houses scattered across a desert plain. Past that, there are only faint wisps, rogue stars, stray clusters, the occasional passing comet. It's still the galaxy, technically, but the sense of belonging weakens, like the last scattering of chairs at the back of a concert before the open field takes over. It's hard to picture what the edge means, because galaxies don't have sharp boundaries. There's no cosmic "now leaving the Milky Way" sign, no galactic fence you can lean on. The galaxy just sort of fades. Its stars become scarcer, its gas thinner, until you're left with space so empty that calling it empty feels like an understatement. Imagine an ocean that gradually turns into mist until even the mist disappears and suddenly you're standing at the lip of nothing. That's the transition from the Milky Way into intergalactic space. Now, let's take a moment to appreciate what it feels like to stand there, if you could. Behind you, hundreds of billions of stars form the glow of home. Ahead of you, an abyss stretches wider than your imagination. The nearest galaxy worth naming lies millions of light-years away. That's millions of years for light itself, the fastest traveler we know, to cross. For us, with engines that can barely nudge at a fraction of light speed, it's like staring across an ocean that not even generations of ships could realistically cross. If the universe were a board game, this would be the square labeled "Patience Required." And yet, that abyss is not completely silent. Scientists have found that even the empty regions between galaxies contain faint whispers of matter. Sparse atoms drifting like lost confetti, filaments of dark matter stretching unseen, and even faint radiation left over from the Big Bang. It's not a bustling street, but it's not a vacuum-sealed jar either. It's more like the last trace of smoke after a bonfire has burned down. Thin, nearly invisible, but still there if you know how to look. At the edge of the galaxy, you also feel the fragility of our travels. We humans have barely stepped off our own planetary porch, let alone wandered into the galactic streets. The farthest we've gone is the moon with our footprints, and Voyager with its golden record is just tiptoeing into interstellar space. To stand at the galaxy's rim in your imagination is to recognize how small we are, how much unstitched darkness lies ahead. It's humbling, like staring at the horizon from a tiny canoe on a boundless sea. But here's the twist, it's also exhilarating. Because that edge isn't just an end, it's an invitation. The thinning stars are like the last dots on a treasure map, nudging us toward something beyond. We might not have the ships to sail those distances yet, but the possibility is intoxicating. The edge of forever is both a warning and a promise. It whispers, "You don't belong here yet, but one day, maybe." It's the greatest cliffhanger written into the fabric of the cosmos. To understand how immense this edge is, think about scale. Our solar system is about 100 astronomical units across, one astronomical unit being the distance from Earth to the Sun. That's a size that feels big until you compare it to the galaxy. The Milky Way makes our solar system look like a speck of dust in a cathedral. Now stretch your imagination further. The gap between galaxies makes even the Milky Way itself look like a dot. Standing at the edge of our galaxy is like standing on the edge of a continent, staring across an ocean not to another shore, but to another world entirely. Astronomers study this rim by tracking faint stars, rogue clusters, and especially by looking at how dark matter behaves. Dark matter, that invisible scaffolding that holds galaxies together, extends far beyond the visible stars. It's as though the galaxy has a ghostly halo, unseen but massive, reaching much farther than the glowing spiral we can photograph. Without it, the Milky Way would fall apart. The stars would scatter like beads from a broken necklace. So when we speak of the edge, we really mean the edge of light, not the edge of mass. The galaxy's invisible hand stretches far beyond what our eyes can see. And still, the romance of that visible edge endures. To think of a place where stars grow thin, where interstellar dust stops sparkling, and where only the yawning dark lies ahead, it stirs something in us. Maybe it's the same instinct that made humans climb mountains or cross oceans. We've always been drawn to horizons, and the galaxy offers the ultimate one. Not just a line on the map, but a reminder that maps themselves end. Of course, standing there, metaphorically, you'd have to wonder, what happens if you step across? Nothing dramatic, really. There's no sudden shift, no border crossing where alarms go off. You'd just drift into intergalactic night, and the glow behind you would slowly shrink. The Milky Way would become a pale streak, like a memory fading in a rearview mirror. Ahead of you, the darkness would stretch on until eventually, after millions of light years, another glow might appear, the faint promise of another galaxy. The thought of it is both terrifying and electrifying. This chapter, this edge, is where we feel both our smallest and our largest selves. Small because we're fragile beings tethered to a single planet, incapable of bridging even a fraction of these distances. Large because our imagination does it effortlessly. We can picture it, we can describe it, we can even send probes to begin the first steps. Every great journey begins with a single border, and for us, the edge of the Milky Way is the border of all borders. And if you stand there, in your mind, on that last strand of stars, on the final streetlight of the galactic neighborhood, you can sense the dual truth, that we may never reach beyond, and yet we might, because history is full of edges we thought were forever, and yet we crossed them. The edge of the earth, the edge of the oceans, the edge of the skies. Every time we believed the edge was final, every time we were wrong. So breathe in the vastness of this rim, where stars thin like threads in worn fabric, and let that paradox settle into you. Fragility and possibility, smallness and grandeur, limits and invitations. For beyond this thinning glow lies not an end, but the beginning of an even larger mystery. What is it that waits in that abyss, shaping galaxies, binding them, guiding the unseen skeleton of the cosmos? That, dear traveler, is where dark matter steps onto the stage. Imagine packing for a road trip where the road is so long that by the time you reach your destination, your car has turned to dust, your playlist has been forgotten by history, and the gas station that sold you snacks has collapsed into ruins. That, in essence, is what happens when you try to think about traveling across the universe. It isn't just distance that looms over us like an impossible wall, it's time. Time itself becomes the heaviest luggage, a weight that makes even the most ambitious dreams buckle under its strain. You can have the fastest rocket, the brightest fuel, the bravest crew, but if the journey takes longer than the lifespan of entire civilizations, what does arriving even mean? Let's put this into numbers, though numbers barely scratch the enormity of it. Light, which races through space at 300,000 kilometers per second, needs over 4 years to get to our closest neighboring star, Proxima Centauri. That's the next cosmic driveway right outside our neighborhood, and that's just 4 years, at light speed. If we took a ship that crawled along at the pace of our fastest probes, you're suddenly staring down tens of thousands of years. Imagine promising your descendants that their descendants' descendants' descendants will maybe, just maybe, be able to wave at Proxima Centauri's planets from a porthole window. It's less a trip and more a multi-generational inheritance plan. Except, instead of leaving behind a house, you're leaving a half-finished space voyage. The cruel twist is that even as you're crawling forward, time is marching on everywhere else. Civilizations rise and collapse. Languages are born, change, and vanish. Technologies evolve from chiseling rocks to firing lasers in what feels like a blink. But your little ship is still out there, trudging along. Think about it. If ancient humans had launched a ship toward Proxima Centauri using our fastest technology today, it would still be somewhere in the cosmic hallway, not even halfway to the destination, while Earth went from cave paintings to TikTok. That's the weight of time. It stretches longer than our imaginations usually dare to wander. But there's a strange paradox hiding in all of this. Time doesn't behave the same way when you're racing near the speed of light. Einstein's theory of relativity tells us that the faster you move, the slower your clock ticks compared to the universe around you. It's called time dilation, and it's both comforting and unsettling. From your perspective inside the ship, the journey might feel manageable, decades, maybe even years if you're close enough to light speed. But back home, centuries will have rolled by. Empires might crumble, continents could rearrange, and your favorite TV series will definitely have ended, rebooted, and ended again. It creates this bittersweet scenario. The traveler doesn't feel the crushing weight of time in the same way. For them, the road is shorter. But the price is disconnection. When you finally arrive, you're a visitor from the past, carrying stories of a home that no longer exists. Your return would be like Odysseus coming back not to Ithaca after 20 years, but to a world where Ithaca itself sank into the sea millennia ago. You're not late. You're an artifact. This paradox raises a haunting question. What does it mean to travel if your destination belongs to a future that has forgotten you? It's like mailing yourself a postcard and realizing that by the time it arrives, the address no longer exists. The weight of time presses not only on our engines and our bodies, but also on our very meaning of continuity. A journey that spans millennia demands a new kind of patience, one that no human culture has ever truly mastered. And yet, humans dream anyway. We design generation ships in our imagination, vast arcs where thousands live and die while the ship sails on. Inside, society becomes its own little world, with rituals, myths, maybe even jokes about how Grandpa once promised they'd reach Alpha Centauri by Christmas. Generations might forget Earth entirely, their sense of home shifting to the humming walls and artificial skies of the ship. By the time they arrive, they wouldn't be explorers from Earth at all. They'd be natives of the voyage itself. The ship isn't just a vessel, it's a moving civilization. Others imagine cryosleep, the science fiction standby where you nap through the centuries. It sounds appealing. Skip the wait, wake up at the destination, stretch your legs and ask, what year is it, like a cosmic Rip Van Winkle? But biology doesn't like being paused. Cells don't take kindly to being frozen and thawed without damage, and even if we perfected it, you'd still awaken to a universe older than the one you left behind. You'd be the guest at a party that started ages ago and already moved on to dessert. Of course, there's the wildest dream of all, wormholes or shortcuts in the cosmic fabric. In theory, if space-time can bend, maybe it can fold too, letting us skip across. But that's speculative and fraught with challenges, like trying to engineer a doorway in reality itself. Still, the fantasy persists because we crave escape from the weight of time. We want the universe not just to be big, but to be traversable. The most humbling truth, though, is that time is not a villain here. It isn't plotting against us. It simply is. Space is vast and time is vast, and we are small creatures with small clocks trying to make sense of it all. The challenge isn't only physical travel, it's learning to stretch our imaginations to scales that dwarf us. To think not in years or centuries, but in millions, even billions of years. To understand that the story of the cosmos is written on a timeline where human history so far is a single heartbeat. That realization changes how we look at our own moment. If journeys across galaxies are beyond us, at least for now, then our responsibility shifts inward. Time reminds us that our window is brief, that what we do here and now matters all the more. The stars might wait, but our lives don't. The weight of time presses on us not just in the cosmos, but in every passing day, in every chance to wonder, create, and connect. So as you picture yourself standing at the threshold of some impossible journey, feeling centuries pressing down like invisible luggage, don't despair. Time's weight isn't only a burden, it's also a reminder that the universe is patient, and that our stories, though fleeting, are stitched into its fabric. We may not outlast time, but we can leave echoes in it. And perhaps that's the true paradox. Time humbles us, but it also frees us to dream beyond ourselves. Because the question isn't just whether we can outrun the centuries. The question is whether something stranger, something hidden in the universe's deeper workings, might bend time itself in ways we haven't yet imagined. And that leads us toward the next horizon. What if the universe has tricks we've only begun to glimpse in the hidden dance of matter we cannot see? Imagine for a moment that humans are not explorers strapping into rockets, but dandelions. Yes, those little weeds in your backyard that kids blow into the wind. A gust carries their seeds, and suddenly the next generation pops up miles away. Now scale that up to a galactic size. What if, instead of sending our full-sized, snack-loving, gravity-dependent selves into the void, we scattered tiny, tough, cleverly packaged seeds of humanity? It sounds poetic, almost like something out of a sci-fi daydream, but scientists are already tinkering with ideas that echo this thought. The universe might be too wide for us to sprint across, but maybe it's big enough for our seeds to drift and root in places we ourselves may never touch. Let's start with the smallest kind of seed: information. In a way, humanity has already thrown a few cosmic postcards into the wind. The Voyager probes, launched in the late 1970s, each carry a golden record, a literal golden disk packed with images, sounds, and greetings from Earth. It's like the universe's first mixtape, except instead of impressing a crush, we're introducing ourselves to hypothetical aliens. Whale songs, greetings in dozens of languages, and even Chuck Berry's Johnny B. Good are now on an endless road trip beyond the solar system. The odds of anyone ever finding them are astronomically slim, but the gesture itself is important. We've already whispered, "We were here," into the cosmic dark. But whispers aren't enough if the goal is survival. That's where another seed comes in. Probes the size of postage stamps. You've probably seen solar sails in concept art, massive shining sheets pushed forward by starlight like a sailboat catching the wind. Now shrink that idea down to a chip the size of a coin, paired with a sail no bigger than your living room rug. A project called Breakthrough Starshot has suggested sending thousands of these tiny craft to nearby stars, propelled by powerful lasers from Earth. They'd weigh just grams, but could accelerate to a fifth of light speed. That's fast enough to reach Alpha Centauri in just a couple of decades, which is practically overnight compared to the timelines of regular rockets. They wouldn't carry humans, of course, but cameras, sensors, and maybe even coded blueprints of who we are. Think of it as scattering pollen across the void. Lightweight, numerous, and surprisingly ambitious. Then there are the more biological seeds. Instead of tiny machines, what if we sent tiny versions of ourselves? Not whole humans, too heavy, too fragile, but embryos. Frozen early-stage humans, shipped in cryogenic slumber inside robotic wombs, could in theory be nurtured and raised by machines on distant worlds. It sounds like the pitch for a very unsettling movie. Think Wall-E meets The Sims, but it's not impossible in principle. Artificial womb technology is already in development here on Earth, partly as a medical solution for premature babies. If that tech matures, why not pair it with AI guardians who could raise children born light years away? Suddenly, our species has slipped its leash without ever physically crossing the gulf ourselves. The ethical questions, of course, crash in like a tidal wave. Do we even have the right to seed other worlds with life, especially if they already have ecosystems? Would those children, raised by machines, even feel human in the sense we understand? And who decides what parts of human culture they inherit? Do we upload Shakespeare, or TikTok dances, or recipes for pizza? The idea isn't just science, it's philosophy, anthropology, and maybe even theology rolled into one strange package. Seeding the stars isn't just about survival. It's about what kind of story we want humanity to tell when we're not around to tell it ourselves. Another flavor of seeding is purely digital. Imagine compressing humanity into streams of code, DNA sequences, cultural archives, instructions for how to build microwaves, maybe even grandma's secret cookie recipe, and flinging it outward on beams of light. Laser communication could, in theory, send data at incredible speeds across vast distances. No physical package, no frozen embryos, just the knowledge needed to rebuild humanity elsewhere if someone, or something, receives it. It's the cosmic equivalent of backing up your hard drive in case your laptop catches fire, except the hard drive is another galaxy and the fire is entropy itself. You might be thinking, doesn't all this sound a little small, a little anticlimactic compared to starships with glowing engines or humans in sleek suits striding onto alien soil? And yes, there's a certain disappointment to realizing we might not be the swashbuckling captains of the cosmos, but instead its spores. Yet there's also beauty in that thought. Seeds are humble, but they're powerful. A single acorn contains an oak. A single spore can cover a forest. A tiny seed drifting in the wind has no idea where it will land, but if it finds fertile ground, it changes everything. Maybe that's our role in the universe, not conquerors or tourists, but gardeners, scattering possibilities across the stars. And the more you think about it, the more it becomes fitting. Humanity itself is the product of seeds carried across time. DNA is a code that has hopped from cell to cell, body to body, generation to generation for billions of years. We are walking archives of the Earth's story, carrying instructions written long before there were cities, songs, or smartphones. The act of seeding the stars wouldn't be something new. It would just be a continuation of what life has always done: spread, adapt, and hope for sunlight. Of course, the practical hurdles are enormous. Building machines that can last centuries in deep space without repair is hard. Protecting fragile biological material from radiation is harder. Convincing the people of Earth to fund giant space lasers instead of, say, fixing potholes is harder still. But dreaming isn't about ignoring challenges. It's about sketching paths through them. Seeds don't know where the wind will carry them, but they grow anyway. So maybe the ultimate legacy of humanity won't be statues, skyscrapers, or even Earth itself. Maybe it'll be something smaller, quieter, but no less profound: a scattering of seeds across the endless fields of stars, each carrying a whisper of who we were, waiting for some faraway soil to listen. And that thought carries its own suspense. If we scatter ourselves like seeds, what happens if one takes root? What would it mean if, light years away, a new version of humanity rises, shaped by alien skies and guided by stories we'll never hear? Perhaps the bigger question isn't whether we can scatter, but whether we're ready for the forests that might one day grow from what we've sown. Have you ever had that awkward moment at a family gathering when someone asks, "Do you even belong here?" Maybe you're the cousin who shows up with strange music, a weird haircut, and opinions about time travel. Everyone stares for a beat, then passes you the mashed potatoes anyway. That's the Milky Way for us. We look up at its spiral arms glowing across the night sky and can't help but wonder, are we just squatters in this neighborhood of stars, or do we actually belong here? Because the big dream, the one we keep tossing around like confetti, is leaving, rocketing out of our galactic hometown and seeing what lies beyond. But before we start fantasizing about galactic road trips, maybe the better question is, why are we in such a rush to pack our cosmic bags? To put things in perspective, the Milky Way isn't just some starry backdrop. It's a colossal city of stars, dust, dark matter, and energy, all whirling around a black hole like it's the galaxy's mayor. Our solar system is just one apartment in a neighborhood of hundreds of billions of others. Imagine a sprawling metropolis where each window is a sun, and each sun might have its own collection of worlds. That's the Milky Way. And here we are, debating whether we belong, like someone wondering if their name is still on the lease. But the funny thing is, we've never paid rent. We were born here. Our atoms were built from its stars. The iron in your blood? Cooked up in some ancient supernova long before Earth was a sparkle in anyone's eye. The calcium in your bones? Forged in the belly of long-dead suns. If anything, we're not tenants, we're family. Still, belonging is a tricky thing. You can belong somewhere and still dream of leaving. Think about teenagers. They're technically part of the household, but that doesn't stop them from imagining their escape. Humanity is basically that teenager staring out the galactic window. We've begun to ask, what lies outside? What's past the spiral arms? If the Milky Way is home, is there something better out there? Some galactic college where we'll finally find ourselves? The trouble is, leaving the galaxy is a little harder than storming out of your parents' house. The distances are absurd. The Milky Way is about 100,000 light-years across. That's so big that if you scaled the galaxy down to the size of North America, our entire solar system would be about the width of a single grain of sand. Walking out the door isn't just hard, it's practically impossible with the physics we currently know. And yet, the dream persists. Maybe it's not about physics. Maybe it's about psychology. Humans love the idea of crossing boundaries. It's built into our myths, our movies, our midnight conversations. There's always a hero who goes beyond the walls, the horizon, the familiar. For ancient sailors, it was the ocean. For astronauts, it was the moon. For tomorrow's dreamers, it's the galaxy itself. But here's where things twist. Sometimes trying to leave makes you realize how bound up you are with what you're leaving. You don't dream of running away from something that doesn't matter to you. The very fact that we think about leaving the galaxy proves how deeply we feel connected to it. If it were just scenery, we wouldn't care. There's also the question of whether leaving the galaxy is even the right way to think about belonging. Maybe the galaxy isn't a cage or a boundary. Maybe it's a parent. Galaxies are, after all, stellar nurseries. They cradle stars, planets, and eventually life. The Milky Way gave birth to us, not intentionally, not with any kind of parental strategy, but still it's the cosmic womb we grew inside. To say we don't belong is like a fish declaring it doesn't belong to the ocean. Even if we someday swim into another sea, our scales still shimmer with the water we came from. Scientists sometimes call galaxies island universes, which sounds both romantic and a little lonely. But maybe it's a mistake to think of them as islands we need to escape. Maybe they're extended families. Each galaxy, with its billions of stars, is like a sprawling reunion. You might not know every cousin, heck, you might not even like them all, but you're tied together by shared history. When we look at the Milky Way stretching overhead, that glowing river is not just pretty scenery, it's a family portrait. And it's not static either. Stars migrate, spiral arms shift, gas clouds collapse into new suns. The family is alive, restless, reshaping itself over eons. Now here's the twist in the story. What if the urge to leave is actually a deeper way of staying? We dream of breaking past the edges, but the truth is, even if we sent ships beyond the Milky Way, the atoms inside those ships are still of it. You could travel 1 trillion light years, but you'd still be carrying the galaxy inside you, the way someone carries the accent of their hometown no matter how far they move. Our belonging isn't optional. It's written in the very stuff of our being. The galaxy isn't something we can stand apart from. It's something we carry in our veins. And maybe the grandest irony is this. Sometimes the dream of leaving is just another way of staying, of honoring the bond by stretching it to its limits. And so we rest in this thought, like a pause at the edge of a page. The galaxy hums around us, vast, ancient, patient. We belong to it, whether we sprint for its borders or linger under its skies. And as we drift into our next part of the story, a question waits. If belonging is unavoidable, then what do we do with it? Do we simply rest in the comfort of family? Or do we take that belonging and use it as a springboard into something even stranger? That's where our journey turns next. Have you ever been at a beach, staring at the horizon, and wondered if there's someone else standing on the opposite shore, squinting back at you? The sea seems endless, and you know it isn't. You've seen the maps, the globes, the Google Earth zoom-ins, but your eyes insist otherwise. The cosmos has its own version of that horizon, only this one doesn't just trick your vision. It plays tag with physics itself. It's called the cosmic horizon, and it's the ultimate "you can't sit with us" boundary of the universe. Beyond it, light has simply not had enough time since the Big Bang to make the trip to our eyes. In other words, there might be entire galaxies out there belting their cosmic karaoke, but we'll never hear a single note. Here's the strange part. The universe is about 13.8 billion years old, yet the cosmic horizon is much farther away than 13.8 billion light years. And that seems unfair, doesn't it? Like being told your birthday cake can't be bigger than the oven, only to discover it somehow spills out into the living room. The reason is expansion. Space itself has been stretching since the Big Bang, kind of like cosmic taffy being pulled in every direction. Light leaving a galaxy billions of years ago had to crawl through this expanding fabric, and by the time it reached us, the distance had ballooned to around 46 billion light-years. That's our cosmic horizon, the spherical bubble marking the edge of what we can possibly observe. Not because there's nothing beyond, but because light from beyond simply hasn't made it here yet, and never will. If this feels like the universe has ghosted us, you're not wrong. Imagine sending a message in a bottle across an ocean that is constantly getting wider. The bottle may have left someone's hand long ago, but if the ocean keeps stretching faster than the bottle drifts, you'll never see it wash up on your beach. That's how it is with galaxies beyond the horizon. They might be out there, blazing with stars, colliding, giving birth to new worlds, but their light is forever stranded. The horizon isn't a wall, it's a speed limit enforced by the expansion of space-time. And just like every speed limit, it leaves you grumbling about what you're missing out on. Now try this thought experiment. If the universe is a book, our cosmic horizon is the end of the chapter we're currently able to read. You can hold the book, you can see the closed pages ahead, but they're sealed until the story allows you to turn them. There's something infuriating about that. Human beings are nosy. We like to peek, to sneak spoilers, to know what's next. But here, we're stuck, pressing our faces against the cosmic glass, trying to imagine the sentences we'll never get to read. Scientists sometimes call this the observable universe, which is a polite way of saying, this is all you're ever going to see, kiddo, so don't get too excited. And yet there's something almost comforting about it, too. A horizon defines your perspective. It gives you a stage, a boundary within which to act. Without a horizon, you'd be lost in infinite blankness, like a video game glitch where the map stops rendering. The cosmic horizon gives us a sphere, a bubble, a sense of what counts as our patch of the cosmos. It's like knowing your hometown's borders, even if you suspect the world goes on forever. But wait, doesn't this mean there could be unimaginable wonders beyond? Whole clusters of galaxies, structures larger than anything we know, maybe even physics that plays by rules we've never dreamed of. Yes and no. Because here's the catch, we can never know. That part of the story is locked away permanently, not just waiting for us to catch up. The expansion of space is accelerating, thanks to that mysterious mischief maker we call dark energy. Galaxies at the edge of our view are slipping away faster and faster, like people running out of frame in a movie you can never rewind. One day, even some of the galaxies we can currently see will drift beyond our horizon. The observable universe is shrinking, at least in terms of what's available to our cosmic eyes. This is where the poetry sneaks in. The cosmic horizon is not just an astronomical boundary, it's a philosophical one. It whispers a strange truth. No matter how hard we try, we'll never know the full story. The universe is too vast, too quick on its expanding feet to ever let us see it all. And maybe that's okay. Maybe the beauty of the horizon isn't in conquering it, but in recognizing its role. It teaches us humility. It gives us mystery. It reminds us that curiosity has limits, and that those limits can be beautiful too. After all, do you really want every secret spoiled? Even the best stories keep a little suspense. But let's not pretend this sits comfortably. Humans don't like closed doors. We've spent thousands of years building ships to cross oceans, telescopes to pierce the skies, rovers to crawl over Mars. To be told, you'll never see beyond this line, is like telling a cat not to knock over the glass of water. It's going to try anyway. And so psychologists keep inventing clever ways to probe the invisible. They study the cosmic microwave background, the afterglow of the Big Bang, as if it's the universe's baby photo, hoping it holds clues about what lies beyond. They run simulations on supercomputers, imagining universes bigger than the one we see, trying to sketch out the unseen chapters. They even speculate about a multiverse, where our cosmic bubble is just one of countless bubbles, like a frothy foam of universes fizzing in some impossible champagne. And here's a twist. The cosmic horizon isn't just about distance, it's also about time. Looking out into space is also looking back into history. Every star you see is a time machine. The sun is 8 minutes old when it reaches your eyes. The Andromeda Galaxy is a couple million years in the past. The cosmic horizon? That's the farthest back we can possibly see. The first light, the universe's dawn. Past that, it's not just too far away, it's too young to have let light shine at all. You're staring into the fog before the universe had a chance to clear its throat. Beyond that curtain lies something we can never glimpse directly. Time itself locks the door. And so, floating here at the edge of our cosmic bubble, we're caught in a strange in-between. We are aware there's more. We suspect it stretches endlessly, but we also know we'll never see it. It's like standing at the ocean's edge, aware the planet is round, but knowing you'll never walk every coastline. The cosmic horizon is both the most frustrating and the most awe-inspiring boundary ever drawn. Which raises the question, what do we do with it? Do we sulk, throw our telescopes down and pout like children denied dessert? Or do we stand in awe at the edge of our cosmic shore, marveling at the fact that we can see as much as we do? Because here's the astonishing truth. Out of nothing, from a universe that could just as easily have been invisible, we can see nearly 93 billion light-years across. 93 billion from our tiny blue dot. That's like standing in your living room and somehow spotting a birthday candle flickering on another continent. The fact that we can see this much is not a disappointment, it's a miracle. And so here we linger at the edge of the cosmic horizon, peering into the unreachable. The universe teases us with its vastness, but it also lets us see far enough to know the game is bigger than us, bigger than galaxies, bigger than time. Beyond this horizon lies the unknown, and maybe that's where wonder truly lives, in the places we'll never touch. As we turn the page of our journey, the question grows sharper. If there is a boundary to what we can see, is there also a boundary to what we can imagine? And that, my friend, is where we're headed. If you've ever zoomed out on Google Maps just for fun, you know the strange satisfaction of seeing your little blue dot shrink against the wide sprawl of your city, then the country, then the entire planet. It's humbling, but it's also thrilling. You're both insignificant and somehow central, because without that dot, all those zoom-outs would just be scenery. Now take that sensation and crank it up to cosmic levels. Imagine pulling back until your house becomes invisible, until the Earth dissolves into a pixel, until the sun is just one glimmer among billions. Keep zooming until you see the Milky Way itself, our sprawling spiral of stars. And there you are. Not as a blue dot this time, but as part of an arm sweeping out in slow, majestic arcs. That's your neighborhood, your cradle, your place in the spiral. And isn't it funny how much time we've spent in this journey imagining escape, leaving the Earth, the solar system, even the galaxy? We've dreamed of faster ships, braver voyages, stranger destinations. But after all the leaps outward, we circle back to something almost tender, the realization that we are already home. The Milky Way isn't a cage, it's the story we were written into, and whether we travel across it or never leave our planet, we are stitched into its fabric, as surely as stars are bound by gravity. Our location, by the way, is surprisingly modest. If the Milky Way were a record spinning on an old turntable, the sun wouldn't be at the flashy center stage. We're more like one of the scratches etched along the outer groove, about 2/3 of the way from the hub. Our arm of the galaxy is nicknamed Orion's Arm, not because it's muscular or heroic, but because from here the stars line up into constellations we gave mythic names. And this spot, this seemingly unremarkable stretch of galactic suburbia, is exactly why life has had the time to flourish here. Closer to the center, things are messy. Supermassive black holes, starbursts, cosmic fireworks that don't leave much room for quiet evolution. Farther out, the pickings get slim. Fewer stars, fewer metals, fewer chances to build planets like ours. But here in the middle ground, we have just the right amount of chaos to keep things interesting without blowing up our neighborhood barbecue. Think of it as cosmic real estate. We don't live in the galaxy's penthouse or its basement. We're in the middle floors. Good sunlight, not too noisy, decent view. The rent? Paid in supernovae that seeded our atoms long before the Earth existed. Every breath you take owes its oxygen to exploding stars. Every bite of food owes its carbon, nitrogen, and iron to galactic alchemy. You're not just living in the Milky Way, you're built from it. If the galaxy is a spiral arm, then you are a fingertip at its edge, reaching back into the very matter of stars. And it's not static, this home of ours. The Sun and its planets orbit the galactic center once every 225 million years. That means since dinosaurs roamed Earth, we've only made about one lap around. Imagine a racetrack so huge you live an entire species' lifetime just moving a few inches forward. It makes our personal dramas, missed trains, lost keys, awkward text messages, feel adorably tiny. But it also gives them a strange beauty, because here we are, conscious enough to notice our place on that lap, self-aware enough to ask, where do we fit in this vast spiral? Let's pause and savor that thought. The galaxy doesn't need you to notice it. It spins whether or not you care. But the fact that you can look up at night and even begin to wonder what arm you're riding on means something. It means consciousness is one of the galaxy's tricks, one of the ways the Milky Way knows itself. Without you, or someone like you, this spiral would whirl on silently, magnificent but unseen. With you, it becomes a story, a song, a home. And maybe that's the real ending of our journey. We've dreamed of light-speed escapes, puzzled over horizons, watched galaxies dance, worried about time's weight. But after all the leaps outward, we circle back to something almost tender, the realization that we are already home. The Milky Way isn't a cage, it's the story we were written into, and whether we travel across it or never leave our planet, we are stitched into its fabric, as surely as stars are bound by gravity. The stars you see overhead aren't strangers. They're family portraits scattered across the ceiling of your room. They don't just light your night, they tell you where you came from. And maybe, if you listen long enough, they'll remind you where you're going. This spiral doesn't end with you, nor did it begin with you. But in this sliver of cosmic time, you get to be awake inside it. That's a miracle no engine or horizon could outdo. So let the stars sing you back to yourself. Let the spiral cradle you in its arm. You've traveled far, at least in imagination, and you've returned to find that your place was here all along. Not in leaving, but in belonging. As your eyes close, the galaxy continues its slow waltz, patient, eternal, carrying you along like a child rocked to sleep in the oldest cradle there is. And with that, our journey ends, not with departure, but with return. You are home, and the universe hums its lullaby.